Hello there. Computers. Okay, so actually let's jump over to this first and kind of walk through some of this stuff. So my scribblings as I was working through stuff, I kind of just made some rough estimates. I'm saying 200-foot span. It's a little over that, I think, but I was just finding some bad drawings that weren't really that close. So clear, I'm saying like from the inside of that column, inside of that column. I'm going to do center line of this structure at 80 feet apart, and then 20 foot out, 20 foot out. Did anybody have any official numbers? I was just kind of graphically looking at this stuff and using my thumb on the computer and wasn't paying that much attention. I knew it was close. I mean, there was, anyways, there's a lot of graphic stuff. I didn't find any hard numbers. But the one that I thought was really nice was this idea of thinking through the one that I'm going to use, pull a lot of numbers from. Oh, come on. Is both this one, which I'm going to take 2.5. Yeah, it's not even, I'm saying 8 by 12. Yeah, it's a little over 8. Yes, it's about 11 and a half, but whatever. 8 by 12. It's approximately the same for both. We'll look at creating variations a little bit. So I'm using 8 by 12 for these sizes just to model quickly. And then this one has heights. And so now this is interesting. I'm thinking through how I'm going to model this and how I want to use it for the project. And so I'm going to talk about kind of different reasons why I might, in Revit, it's all about levels or reference lines, right? So I'm going to build this in a real project. So I want to know, I got to think through it by what my reference lines are going to be. Because as soon as you understand that, I guess that's actually a perfect, that's why it's hard when you're a student jumping in trying to design in Revit, because you don't have these things determined, right? But in any real project, you've got a pretty good idea of the number of floors you're doing and things like that. The dimensions will change, which is why the variability is nice, but you would have that stuff sketched out already or figured out some way. So I'm looking at this and I want to take that as a reference line, and I'm going to say bottom of roof beam, but I'm actually going to take the second one to be that as top of floor beam. And then actually you can barely see it here, but the hanging floor is right here. And then this is the street level. So for me, I was going to determine these things as my levels. Okay. Boom, 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 boom. And then, so with those being like 12 feet, we got some dimensions here. My dimensions end up going. So that was my logic. I'm going to draw those out first. And then I use these numbers, but manipulated them to get the dimensions from there. So my scribbling. Yeah, that doesn't line up. I'll delete that. Is I wanted bottom of the beam, top of that beam, top of the slab there, and then act grade. Okay, so that's why I was starting with these dimensions. I was looking at it, it seemed like the beams that were repeating are about 2 foot or 2 meters, so about 6 feet. So I've got 6 feet and 6 feet. But there's some weird stuff that happens up here. Remember, as we were drawing the, not that axis, as we were drawing this axis, on the idea that this 2 meter beam here, 6 feet, is about 2 feet up and 4 feet down. So that this is my datum line, right? I'm gonna have to shift this beam 2 feet up, let it be 4 feet down. And I'm also gonna make sure that this peak is under 4 feet because it's slid underneath that beam, right? Those were kind of some important things about that weird detail. What was nice about the lower floor is that this is why I was making that the level, because I want these things to just all snap to that level. So I was just thinking through how I knew it was going to unfold and how could I just use the levels in the easiest way. Make sense? We could have done the ceiling, but the ceiling isn't flat. It's the bottom of that beam. So I just figured I might as well use the big beam for that. Okay. I sketched through how I would think about the diagram or what I want to blow apart. We'll talk about this after we get it modeled. Remember when I said the other day, we're going to look at using the roof form profile to do this. We're gonna have concrete beams here, but we were gonna try, did anybody try making a profile and loading a profile into something? Yeah.
2 ways. One we got from all, so people will be operating.
The void didn't operate correctly?
So
Yeah, I can see that.
like offset.
Yeah.
And so that never, but I got one word that it's attached to the frame, so it should, but it's not very loud. Then I tried to create profile and did for the people, and they create something like that, and they make it stretch.
Yeah. So there's another way, we're gonna do it, we're gonna do this, we're gonna make this thing kind of the way that Revit wants to think, which is actually just really simple in some ways. It's like standard stuff. Okay, so we're gonna make this. No, let's not make this first. We're gonna set up the project first. Because I want to get these levels all set, because when we bring stuff in, I want to just be able to make sure I'm snapping it to the right places. So, whoa. I got a project. I don't have these set yet at all. Let's rename some of these. I'm going to say, I'm going to make this foundation. I'm going to make this street level. Okay. Don't show me this again. Yes, I want you to change everything. I want to make this hanging floor, let's say top of hanging floor. And then we're going to have, let's say, top of gallery beam. Actually, with gallery, let's just say gallery structure. Okay. And then bottom of, oh, don't hit them, of roof beam structure. Okay, so this would be kind of some stuff, but none of this is correct, right? So I had 70 feet. If this is, I'm going to put this at street level at 0. Okay. So that means I can go into this one, and this was at 7. Oh, I hate that. 70 feet. Doesn't matter, we'll draw that in later. And then this is at 70 minus 22, 48. This is what I have, like rough estimates of stuff. I've got 22 foot from there to there as an estimate. And then I've got 20 foot below that. So that would be 28 feet. Okay. So those are my approximate levels, 70 foot total. Those, in essence, 4 floors floating about that high. That seems proportionally about where we were at, right? Uh-oh, chat. Yeah, the void is hard to make me do that. Yep. Just different way. Okay, so now let's look in plan. Okay, save project. Let's actually do this the real way. This is BoBardi class whole way. Yep. Come on now. First floor. Let's draw some of this out. What did we say the dimension was? It was let's say we wanted this to go let's see 80 plus 20 and 20, that's 120. Or 120, not 12. Okay, and our inch there. We want this to be 200. Well, that'll just, we're gonna, I know you get so mad. All right. I'm sorry, what? Doesn't matter. I don't know what I'm doing with that. Why is that? Does anybody know what I'm doing wrong when I grab this thing and it clicks the other way and it doesn't freaking, like, Why am I not getting that? Like, what dumb thing is happening that this point? Oh, man, I think there's a sensitivity on my mouse or something that's just killing me with that.
You have to
So
change it from 2D to 3D.
from when I'm grabbing that, oh, I'm
Yeah,
changing
it's
the,
like a little symbol.
so it's, yeah, because I want it 3D as a plane, so that's interesting. But like dragging it out, like when it doesn't let me drag it, I'm like, ah! It drives me nuts. Okay, so you just calm yourself. That proportion doesn't look right. So look at that. I don't think I got those proportions right. Anybody else have some overall dimensions for this that are even close? Like, I'm not even close to those proportions. That's way longer. That must be way smaller. Anybody? Did anybody look up the dimensions of this? About that? There's a dumb little key here. Because I was just looking at that and saying, okay, if that's 20, let's say outside to outside's 20. Under 5, but that's closest. Yeah, I see. It's the wings that are small. The spread is about right. It's that this is probably outside. They'll go to the outside of that. This is probably like 50 feet. And then that'll be the outside of the, actually that's what I'm gonna do. I'm gonna make this 70 feet. And then still keep this 20. Nope, no. Gotta grab the right one. Because I'm not locking any of these and I don't have the center line on them. I gotta grab the one I want to move. That's closer. And then they're going to be outside over here. They're going to be centered right there and centered right there. Okay. So I'm gonna do this and say this is gonna be interesting. End one. And let's say I'm gonna label this one front. Now, what's interesting is there are times where we want to draw and it wants you to pick a plane. If you label one, it's easy to pick out the one that the direction you want to look. It's a dumb thing with some of us. All right. So let's go in and we're going to make that, but start it over again. Okay. So we're going to make a profile first. I'm going to say file, new family, profile. And so there's a whole bunch of hosted millions, all of these. I'm just going to go basic one, open, and it notice it. So what we're doing is that's like center. So that's the 0 point. I know I want the beam to sit, in essence, I want the beam to sit up here. That way it's like the center line, that's going to be my structure line that I'm going to draw. That's what I kind of want to have happen, right? So there are two different ways to do it. So I'm going to draw this profile and say, I want, let's do it, RE. And so then I start making, I want to control this, right? And we want that to be freaking 12 feet. So that's pretty big. And we want the equal. And we want that to be sometimes. Why does sometimes it just not? All right, you could do it another way too, where you tell this and funny when I can tell when I'm just like not thinking through it. So we wanted 6 feet, 8 feet, so 4 foot there. Oh, don't know why that was. Okay, so this is going to be the reference lines that we're going to want to work with for the object. See, sometimes it just grabs them so easily. But what I'm going to do is I'm going to do some offsets because I want to make sure what I'm drawing that the idea of the thickness, right? And so I'm putting a top, bottom, and edge. And DE. Let's get some dimensions here. We can make, we could set each one of these to have a parameter. But I'm just going to like lock them to a size. So now they all have a dimension. So I can grab this one and say, I want it to be, actually, let's say like 6 inches here. It's small, but we're going to make these width ones bigger. Let's say 2 feet, big chunky things. Make this again 2 feet. Again, we can make these parameters like we normally would. And we're going to make this one, let's say 1 foot. Okay. Okay, now we have all this. Now we should be able to just, what I want to do is we want to create line work. I'm just going to draw boxes. I'm going to draw a big box. Actually, we already have 1 box. I'm just going to draw a second box. Doesn't even matter where I put it. One of these is going to be the outer one. One's going to be the inner. AA, lock, lock. That's the bottom. Oh, I locked one of the, oh, that's just the dimensions visually messing with me. Okay. So now we got our profiles. I'm gonna file, save as family. I already got one. I'm gonna relabel that. Yes, override it. Okay. So big chunky thing, not much detail. I usually start by just getting this stuff simple. This is why I say, like, when you're working on a project, the idea of just getting some basic stuff in and getting the logic together is what helps you come back and refine it later, right? So we can actually load this straight into the project. Override existing. Okay. Now, one way to do this. Now, we've been playing around with massing, in place mass, and that's one thing, but there's actually a separate, this is so confusing, and I get why they're doing it, but it also kind of drives me nuts. Within architecture, there's components. And if you want to model something in place, this is if you want to make the object that you want to see. Massing is if you want to make a 3D mass that you then make a curtain wall out of or something else, right? If you want to make a mass that disappears, but the logic is there, you use in place mass. If you want to make an object, you actually go model in place object, and you can say what I want it to be. I want it to be a structural framing. Okay, so now it knows it's structural framing. Okay. And now I'm going to do a sweep because I know I want to use the profile, and the sweep uses a profile. So sketch path. Now it's asking, it's our set to top of hanging floor. Now I'm just going to draw it exactly on that line where the center line is. That's what I wanted, a center line, escape. Yes, that's good for the path. Select profile. I've loaded in my profile concrete big beam. Good to go. DD, got myself a box. That's all it is. So it's an object, just like if you loaded in a chair, any of those type of things. Actually, it even rotates. That's funny. Huh, hadn't literally looked at that. Hadn't hit space bar with it before. Wow, that. Oh, it's rotating it off. That's crazy. It's rotating it off a center point over here. But you might look at, when we look in elevation, we might see it's not at the height that we want. The hanging floor, that's not where we wanted. We can actually grab it and say, edit in place, grab that object and say, I want to put it on a different work plane. I want to put this on the bottom of roof structure. Okay, so now I got one at that level that I wanted it. But now I also wanted one at the top of gallery, but I needed to be here, but I needed to be down, right? Because we wanted the top of that there. So I wanted to do this again. Actually, let's see if it allows me. I don't think it allows me to copy. It might allow me to copy. Let's see what happens. It's messed up. Control copy. Control V. Yeah, it does. Okay, let's see how messed up this gets. Let's see if it's, nope, it's grabbed it back up there, right? So I'm going to grab this. I'm going to say edit in place. Grab the object, say new work plane, gallery structure. Okay. But now I can say vertical profile. I want it to drop minus 12 feet. Okay. Now the top of it's where I wanted it to be. Okay. Now we can also go, I should be able to, let's see if we finish it just AA, because it is an object. So we should be able to, yep. Okay. So we're just able to AA it there. We got the 2, which means we should be able to go to like roof plan. No. I want site plan should be, yeah, okay. I should be able to grab both and let's say copy there. Got both. All right. Okay, so this was just making a profile and using, and this is what was weird, is I hadn't really played with this before, is the idea, the massing, in place mass. Think of that as when you're sculpting a form, you want to use it for something else. It's the logic that it's like you want to do a curtain system, you want to do a giant mass, then subdivide floors that you then lock stuff onto, versus architecture component, you want to model a cool, crazy thing like a weird desk or something. Okay. That's one off. So that got us started. Let's go WW, get rid of some stuff. So we could change some stuff in there, but the solid void came through correctly. So I was happy about that when I tried it this morning. So profile, I just drew 2 lines. It has no idea. There's no object here. It's just 2 lines. But it knows it's a profile, so it knows it's a profile, and it's not like when you say sweep understood the profile is going to have solid void. I guess the logic's there. We could also probably load this on. Let's try one other thing. Another way to use this, if you don't want to do it in place every time, but you want to make your own beam, let's say file. I've done this once or twice. I haven't done it with this one. So let's do a generic model line based. Okay, so now there's a line, and we could say create sweep, pick path. There's already a line there. Well, we might as well load the profile. We can just load it. Load the profile in. You got to select it, which is silly since you just loaded it in there. Good to go. Oh my goodness. Now it's this short little thing, but this is a line-based generic model. So when I bring it in, I snap 2 points, the line goes in there. Brilliant, right? So this is where, if I want to snap it around. Now, if you click always, I think you can, so think of this as like a really strict version of a 2-point adaptive. The 2-point adaptive could go anywhere, and you could screw up orientation and all this stuff. If you're just making something that's going to function just like the structural beam that you want, then this works, right? So let's say file save as. Let's do this PMD line-based concrete, big concrete. Let's do BoBardi concrete beam, if I know which one it is. And I'm going to load that into the project. Well, we should have said it's right now. It's probably generic model. What happens if I grab there? Yeah. So it's grabbing whatever plane I'm in. So if I'm in this plane, like to grab from here to here, so you could set the plane, but you could go in other angles. I'm not, it was a plate on worth, so I could select face. That's what I'm doing, is I'm just going in and selecting a face, and it's understanding that face and then putting it on that face. So super useful that way. Work plane, you could set the work plane that you want to do it and draw it on. So it's actually really useful. That's crazy nice, actually. Because then you can even offset a distance. So offset it 4 feet. And it just offset it 4 feet. Pretty nice. I like that. So useful. You're not able to go, it seems you would have to have a work plan. So if you have a sloped roof, you might make, like if we're in I might go in one of these. And so if I'm making a sloped roof, let's say east, let's say if this whole thing was going to slope, I might go make a slope pitch, name that sloped roof or something, right? Then I go back in the DD and I could go, hey, I want to drop that beam on a weird, family. And right now it's coming in generic model. And I have it in here and I can say place on work plane. And I should be able to say sloped roof. And I'm on that sloped plane, right? So there's just ways of thinking through how do you want to use it. Goes east to see, I'm like on that slope plane. The way of being consistent with that type of stuff. I wonder if you could flip it. Yeah, it doesn't look like you can flip it. All right. Anyways, it's not what we're doing for this project. So let's look at how we're going to do the floors, because each one's different, right? So I want to start by kind of loading in a concrete beam, because we're going to put it in the generic concrete beam and see what it is. Oh, I didn't look at what the pacing we got spanning to. We're going to keep it simple. We're going to keep it spacing equal something. So I need to insert load family. Actually, let me do structure concrete. We get certain. I want the objects. Went to beams. Structural framing, concrete. Aha. See, I don't know why it comes up a certain way. Concrete, regular, load. All right. So now we got this kind of basic thing that's in here. Should be structural framing. Structural framing. Concrete, regular. There's even a few basic ones in here. Actually, I hadn't looked at what those dimensions are, but we were saying they were 6 feet deep. So let's take one of these. I'm going to take this one, duplicate. Actually, let's just go in and edit this one and change it. Rename. Let's say 12 inches wide by 72 inches deep. I'll keep doing that. Okay, so base, that's staying the same. This 6 feet. Okay. All right. So now we got what is going to be our beam. So now that's a structural framing that we can bring in for the beam system, right? That's the goal of that. We're trying to use some basic stuff. Let's just go to first floor. Doesn't matter. I'm going to say structure framing. Just going to draw a box. AA. And I need to make sure I don't want them going this way. They're crossing. So changing the beam direction to there. And concrete rectangle is already selected. I want this 12 by 72. We could change that after the fact. This is 20 foot or 200 feet. Let's just keep this let's go to 10 feet just to keep this kind of simple. And I'm going to say max spacing just to see what Is there? That's a lot. We're gonna go 15 feet or so. Let's check that and say, it didn't actually do that. That's weird. 12 feet. No, 12 feet wouldn't be right. We want increment of that. Let's say, that's looking about right. Let's do 15 feet. That should work. All right. I don't like this. It's clear spacing. See how it works out. Whoa, what are you doing? No, clear spacing. From center. I don't like, so we can actually offset stuff too, like shift it a little bit left and right by manipulating the pattern, but like we can say from one side, from end and manipulate this. I just like, let's say fixed distance 15 feet from center. Let's just start with that. Okay, but it's not at the level we want, so we got to make these things at the level we want. So edit work plane, we want this one to be, let's say, at the roof, bottom of roof structure. Okay, but we also want it to be up a distance, right? Elevate 2 feet. Okay, now we got the interlocking. All right. So copy. We can modify, paste to selected levels. I want to put it at the gallery structure floor. Okay, boop. Dropped it down, perfect. Now, but I'd already had this one up because it copied the up. So now on this one, I got to grab it and say, I don't want you to be up 0. I want you to be at 0. Okay. So now I got the one hanging and the one there. Okay. This view is killing me. All right. The shadows were getting a bit much. So things that we want to do now, we want to, this cool ceiling. So let's go into a view. Actually, I'm going to start with, I'm going to go back to the with this view. I want to draw a roof, and this is why I drew those when I named the front and side as planes. It was a cheat because I know that I like to draw roofs using profile of extrusion. Most of the time I'm doing a roof, it's a shutter or a or even if it's complex, it's one direct. It's even if it's a pitched roof, even if it's a split pitch roof, you can still do it by extrusion. So, but it asks what do you want to use? Well, now I can say, hey, I want front 01, okay. And it's going to open. Oh, that's funny. Normally it opens the view that I want to see it in. Nobody normally asks, do you want to see it in that view or this view? Okay. Now we can just draw lines in here. If I just draw a line, it's going to make whatever roof form we want as a roof, right? But so we want to make it what we want now, right? So I can come back and edit that, or yeah, let's just actually edit that. Back into this view, and I'm going to just delete these. But so what I want to do is we actually want a middle point. I'm going to draw a grid line out. No, let's just do it once and repeat it. Let's see what happens. I'm going to go. I want a midpoint right here. If I had drawn a grid out for the project, I would have the grid for all of these there. That might have been one way I would look at this, and I would change the grid. I'm actually just finding the middle of this by doing that and hitting equal. No. I just want that to move. Why would that? Yeah, but I want this, this is the thing I want to move, 7676, okay. So now what I'm gonna do is I'm drawing a profile that goes from there to there. So even if I just do this and go boom, boom. Okay, I can actually take that, copy, and for some reason it doesn't like array. I found that when you array a profile like this, it arrays one over and then all the rest sit on the beginning. So we could look at that and say, okay, well, I'm getting what I want underneath. But there's something that they're actually, the project's way more sophisticated than that. It actually rolls. It actually has a radius here, which is really nice. So I was playing around in ways of getting that. So let's say Control Z. Z. Okay. So I'm going to take this. Instead of copying the object, I'm going to array should work on this. Won't let me array right now. So copy. And this is super annoying. I hate doing anything multiple times. It means something's not. It means we're not. Whenever you're doing something in a repeated way in the computer, you're not doing it the right way. Just know that. Okay. Now what I want to do is I want to make this a radius so I can actually go, hey, I want that one. And I want it there to be a radius, and let's say 6 inches. So now I'm just going to grab this and this and this and this and this and this. And that, and that, and that. That's why it bothered me that we couldn't, oh, did that not? Yeah, let's do it. That I couldn't repeat the radius a different way. Oh, I'm not good at that way. And we get a nice rounded finish there. It's kind of nice. I realized, we could have done. If I wanted to copy the, well, it doesn't matter. Now it's one object, right? Now at the same time, we could just do, so if it's, when it's off, what's nice about these roofs is you could just drag and drop it to where it wants. You could lock it. We could have looked in plan and align it to the levels, whatever we need to do, because it's that type of object, right? So other things that we want, okay, so there's actually another system on this of elements going the other way. So when we look at that, when we look here, there's actually little tiny concrete beams going across, right? And so we could say, let's say if that's 6, let's say they're about 1 foot deep, and maybe every 3 feet or something might be fine. Let's just do that as a repeated element. So I'm going to grab this. I'm just actually going to make another beam system crossing through it because it's concrete and would have been cast at the same time anyways, right? So I'm going to say, just for clarity's sake, I'm going to say Control copy. This will be kind of weird. Sometimes I like seeing it somewhere else and then putting it back. I'm going to say paste on selected levels, basement level really quick. Now I see it down here. Grab this and say, edit. I want to switch the direction to here. And then we're going to make a different beam to go in here. So we had the concrete down here that was this way. And I'm just going to take this other one, double click on it, rename. And we're going to say that these are maybe like 6 inches by 12 inches. That. And then inch. Okay. And so now I can grab these. I can just grab this beam system and say, I want you to have that one. And I want those to be at 3 foot center. Okay. Let's grab that and say, I want to put it on a different work plane. I want to put it back up to Okay. I could come through where they shouldn't be. You could actually just delete. Oh, just calm yourself. You can, you gotta unpin them. Actually, it's unpin. So we can do that, clean up stuff if you want it. All right, then we can just throw a slab on there pretty easy. We can do the same thing for the bottom, actually. So we're just gonna say we want architecture, floor, picture floor. This is probably just floor, that's fine, whatever, it's. Yeah, whatever. Let's go into the. Still in floor. There we go. Again, just drawing a stupid box. Okay. And I'm going to say 12 is a bit 4 inches. Top of hanging floor. Oh, that we want it on that one. I'm just going to start on that one too. So we can say that's good. Okay, so there's the hanging floor. And I'm going to control copy. I want that on the gallery. Okay, but we actually want that up 4 inches, right? Because that's right now in the same place. Hey, you could actually argue that it's probably at the top of that, but it's going to render really weird. That makes sense. Like the alley, it's probably all cast. Actually, the beam was probably cast first. Yeah. Let's say 4 inches. All right. For now, that is getting there. Oh, now we want to hang. We want to hang these things, right? So this idea of bringing in a thin column. Let's go load. Yeah, we'll actually load a real one. We could. No, insert. So load family. I wish I got. We could go in and say load family or load auto. I need a key in for this because I hate having to go to it. So I got to change a key in for that. We could look up that. So I want structural columns, light gauge steel, magic aluminum. Channel. Yeah. Oh, whatever. It should. I want to. I don't want those. I want actual column. Channel furring. No. It wouldn't be a. Aren't you giving me other sections? There should be a. There should be pipes. Those are the cross sections. I actually need the object though. That's detail items. I don't want detail items. I want the. I wish I actually separated objects just out because it would be so much easier than having them in the same thing. But anyways, structural columns. Yeah. Ah, that's why. Okay. One of these is going to be yeah, hollows. You know, it would be solid, but these are gigantic. We want smaller. What's the smallest? We'll take that. 2 inches. Yeah, we'll take one of these. We should have done solid. Solid would have been able to get smaller. So it's a column. So again, this is where I just jump into plan. We know that those are actually they're going to be offset from this line. We could draw We could do that and that. And because we want it to be kind of, they're not on the, they're let's say 3 foot, they're on the edge. They line up with the center of the thing. So I'm just going to drop in a few. So the idea that we'd be dropping in there. See where it ended up. So it's all down here right now. I'm just going to grab this and say, I want it to go base level. Let's say top level is actually gallery structure. Yeah, that's fine. Base level hanging gallery. Oh, sorry. Top level, top of gallery structure. There we go. Okay. So then I would start to kind of go in through and we could copy and array that. Again, this is where I probably should have set up a grid for these, because then we could have just locked all those beams to the grid, because I have this based on the beam system setting. But we could have snapped these to a grid, and I could be snapping that to a grid. I wonder if we, if I take a center line, let me, yeah. Because I can grab that and probably grab that, and it centers, or it's on the edge of it. Yeah, I could do that. Now it's on the edge of that going up. Yeah, we could copy a few, make sure they're. Got one on each side. That's a start. Yeah. I haven't been able to get array to work freaking once. Okay, we can leave it a group associate to the second one, move to the second one from here to there. But I want, let's say 15 of them. All right, fine. Man, that's been, no, I only need 13 of them. Okay, finally good. Freaking not to work. All right. So let's say that's a good start. Let's just do a lump column for a quick second so we can see, we can start to look at some views. Not all that stuff. Oh, I could use that one. Let's use this one and I can make columns with that. Let's just do in place mass. It'll be simpler. I'm going to look at first floor and say, and I'm just going to do basic extrusion. So this to be, yeah, 12 feet. And I want this to actually be 8 feet total. I should be more accurate at this, but we're just going to get it. There we go. And what's interesting with extrusion is you can copy it and it'll do both at the same time, no problem. Gets it. And we want to make those. We could just AA it. Okay. All right. Now, I'm doing this because I know I'm gonna cut it down to look at a portion of it anyways. This is why I probably wouldn't, there's one thing, I guess we could just copy that really quick. There we go. So let's talk about what diagrams we want and why. So to me, this is using, you could be doing the whole edge detail, like how far can you take this? There's a great roof edge detail, the whole gutter thing. I might do that as an a in-place model like this, because it is a pretty unique thing. I don't think I'm going to be reusing that gutter in a project. Right. So this is where like the difference of modeling something as your own component versus modeling something in this. That might be a detail that you do in here because it becomes pretty interesting. Oh, and the fact that this column, there we go. That's what it needs, is we actually need to go to the full height. Because these were not going. We need the actual ground floor. No, not that. Yeah, that was fun. Tab. There we go. Okay. And we just need another floor to represent ground also. So I'm just going to do a stupid floor. And let's put this at street level. Okay. There we go. That's looking more like we're supposed to happen. So let's say this is a starting point. I'm going to save, and then we're going to sketch a little bit, figure some stuff out. Perfect. So, questions on that? If I was to have done this, that was trying to do it as fast as possible just to get some stuff down. And it took about 40 minutes. There was some content creation. I think if I was doing it really, I would have done probably grid lines on what I wanted. I might have done that as a way of locking stuff together, because so many things are lining up. It's one thing to do beam systems when you just want an array of them the way you want, but the fact that they lined up the big beam above with the beam below with the tension cables, that's like a logic through the whole thing. So I want to control that logic, right? So I probably should have done that this way and arrayed it the way I want. That would have probably been a little more control because of the follow through. Probably be the one thing I would do differently. Yep. I was trying to do it quick. If I was again to spend more time on it, I would look in plan. I would offset, I would align them to that surface. So we could actually just grab all this and HH. Oh, I gotta look at the level that those are on. Oh, we didn't rename these. That's stupid. What level was the? I'm just gonna do this. HH. You know what? It's not. This views aren't showing me structural columns. Is what's the issue. So I have to go in and change the visibility. I tend to, when I'm using actual structural components, because a lot of times the visibility it only comes in as a line depending on what setting you have it on. Here they are. So the idea of coming in and making, because I copied them, mass group array, right? So I can go in, I should be able to go AA. Yeah. And they should all change because they're actually underneath the thing, right? And it's actually 4 of them. So let's just, like if I was doing this correct, I would have set all this up. And now that should actually correct the array. So again, this is why I go like, get it in place, get it close to what you want. That might have been a week into the project that I start to refine that tolerance. I might have just dropped one of them in there to get this going, right? That process of being able to edit and modify it is the thing.
And also, I think it's for the things instead of model.
Well, so you can do it as a generic model adaptive. It gets a little fussy. So what happens is you have to set it to a work plane. So you have to put the point in there and you have to set it to a work plane. I have found to get it to work right, it's how you draw it. I draw it in plane and then it sets up correctly on the work plane. It's a fussy thing. This tends to work 90% of the time to what you want. It just depends on how crazy it is. If you want a whole bunch of different cross sections, let's just sketch, because that was enough of that stuff. If you want to be able to snap a whole bunch of points and have a weird form and have different cross sections on it to make a different shape, then you have to use the generic model adaptive. You set points, you draw a spline on there. You also set points, and then you have to make a generic model adaptive with a single point and the profile on it. So you have to draw the profile, load it onto a point, then load it into this, but you could have crazy different cross sections that are making really crazy forms. You can also then set this to where you have a reporting parameter and have that shape change based on another point, but it means drawing the profile in the profile, loading the profile into generic model adaptive, loading that generic model adaptive onto stuff. It's a crazy feed, but you can get super complex forms that are reactive. That's 3 files just to get this. So the profile has to rest on a generic model adaptive point to then be loaded onto this independent. No, so this is a profile is generic model adaptive. Then that generic model adaptive is hosted into a generic model, another generic model adaptive with a spline. That's how you get a crazy changing cross section. You don't need to do that if you're not changing the cross section. That's my point. So the generic model adaptive way of bringing a profile to generic model adaptive is only if you're doing a crazy amount of profiles, you want it to change cross section. Otherwise, doing exactly what we did there, we're just loading it in as a sweep. You could even sweep multiple shapes. You know, this is where playing a bit in let's just do this real quick. The different forms that you can make, that was the straight simple one. When we did the component, it doesn't matter, just pick something. You could do some really complex stuff with Sweep Blend, because that's what it's doing, is you're loading different profiles onto it. So actually, you can almost do this with Sweep Blend, because you're writing you're drawing a crazy spline and you're loading different cross sections at different points, and it figures it out. So you can get a crazy, you could do an entire snake with a tail, it eating a cow, its head, neck, you know, because you just put in all the cross sections and it figures it out, and then you can draw that spline where you want. Right? This is actually just straight in project, but you would only be able to do it once here, and then you would have to, it's not a component that you have to use again. So that's what I was showing. In a project, you can do model in place and do that. Those are the same tools that you get in generic model. I tend to like generic, like that's super complex. Like you want a crazy snaking form that changes and reacts, and you want to use it more than once. That's a nesting of a whole bunch of stuff. That's far beyond. For this, let's talk about how would we work through diagramming what's important. So for me, I was thinking through it and I realized I want you to both learn how to explode in a way that's effective, not just people hear this from me a lot. I don't want equal bun, meat, lettuce, cheese, lettuce, equal. It's not about everything being equal. I want some type of editing. Just don't explode a burger and show me every piece, right? So how can I tell the story that I want to tell here? And I was thinking, it's like, oh, I want the two beams to be up, because I think there's something interesting about understanding that these that the roof elements are hanging. So I want to show that those have a certain relationship and that the floor and the other floor have a different relationship. So there's one system and a different system. So I might even push this far apart. So let's say at the top, oh, that was the other thing. I would probably do a plan. Because I want to show this is a big project and I want to show a lot. I would show the columns. What are, I want everybody to think through something. The idea of what is the amount of weight that we're bringing down in, total trib area and amount of weight. That's one thing. So we could just calculate trib area, right? So let's say if we labeled column A, B, C, D, we could say trib area for A is half the distance here and half the distance here, right? We could say that's the trib area for column A. We could put a square footage on top of that. I would like you guys to start being graphic with text instead of maybe listing stuff on the side. So how can you incorporate, how can we look at that and understand it's X number of square feet embedded into that? Okay. But now what's interesting is on the same plan, I might also do a graphic that shows axon, like the idea that I'm actually just, you're telling me what we're looking at in the axon, and that it might not be the whole trib area. So now all of a sudden, this little key diagram is letting us know some information, you know, total trib area that I'm talking about, the column and the location in the building, and hey, the axon isn't the whole thing, it's just a chunk of it, right? Now I'm picking this back one because I like the idea of seeing the cut. Let's look at this, the idea of the cut of that chunk. So we're seeing the big beam. I like the idea of understanding that, and I like the idea of seeing the cut and the cut. That makes sense. So I'm looking at this back column from this direction. So I'm seeing the cut edge of stuff here and the cut edge of stuff there, right? Because those are different things on each floor, right? Because some stuff spanning one way and some stuff spanning the other. So now this whole axon is going to show me two great views, right? So on this one, we would have the, there's the beams. Every X feet of whatever it is. So now what's nice is by doing the diagram of where the axon is and that it's not the trib, but we're understanding the trib, it then allows us to kind of edit this axon to be graphically what we want to read correctly without being forced to be the whole trib or forced to be the whole building, right? But we're letting somebody understand that really clearly by that diagram. So what I think is what's important to do is to maybe show clearly that, yes, this is normally nested up here. I might just take one of these and dash in where it would be so that we understand that it's interlocking into that beam, right? Or maybe I don't even dash it in. Maybe I just put a gray mark showing like where these would be, like, you know, actually you could notch those. That would be great. If you notch those, that would say it, right? If you notch those and then we saw a dashed line where they hit, we would totally get if those are hanging from there, right? The more I zoom in, then the more I've got to make sure and move my move it when I start drawing in other places. Well, when I zoom. Okay, so we got that. We're also going to have the up and down and up and down. Right. So those are all in there. They're seeing all that happening. So all of this is going up. Now, this is what's interesting is we might say, what's good? There's the roof, there's the ceiling. It's gonna look down. Okay. I'm gonna give a big break and show the floor below really apart. So we see a clear distinction, because to me it was like, these are going up to come down, and these are going down to come over. It's gonna be kind of the story we're telling, right? So I might, this floor, this is kind of interesting. Floors are sometimes, there's a lot of times in Excellence, I just I won't show the floor, or I'll just dash the idea that there's an architectural slab or something, like finished architectural floor, right? So that way we're just already going through it, right? We've got our big beams lining up directly with these, and they are diving into the big one here. Right, so we got 3 of these. Now, I could have exploded these off of that the way I exploded here, right? So I'm kind of exploding this off a dimension, right? These are separated, so I can talk about that distance. I might not do this here because it is pretty clear that it's well, what I want to really talk about is the fact that the other one's hanging, right? So it's like, I like the idea of just saying, hey, look, this is at one level, there's a slab on it, these are on this. We could show the other little ones going this way. And this is why I say, like, yes, we could explode every one of these things, but frankly, that's not what's interesting about this project, right? So I'm editing what I'm exploding to really highlight what's crazy, okay? So now all of a sudden we've got this cross section here, again, of this cross section here, that, the edge of maybe the roof being cut there. We've got maybe the end of these little guys sticking out, right, to kind of tell that story. We see the little ends of the joists that are going there. Now, although this is things hanging, I would probably again drop farther this floor. Yeah. Oh, sorry. And it's 4 kind of together and 4 together, right? And it's kind of 4 together and 4 together, right? And it's 4 together and kind of 4 together. Does that make sense? So we would see, and then what I might do is just dash a line up to where these attach, right? Now, you want to really look this up. I might have, depending on how graphically I want to do it, if it was all about the total weight, I might take the column all the way down to here. I put a line right up there. Might even have the whole project down here. Might even have like a, sometimes it's have the column down here, but then a ghost of the whole thing happening. Does that make sense? Sorry. I'll zoom on it. So I might have the actual column down here, but we have a ghost of that beam and a ghost of this beam, right? So this might just be some dashed lines or some different things. We kind of understand where these are falling into place, right? I always like that sometimes that there's some reference to the whole and then the things are exploded, which means there's duplication of information but at different levels. It's solid here, it's dashed here, it's, you know, whatever. I think that's why it's I want you to get in the habit that it's not just one export as exploded. You have to learn how to export multiple things to get it to read the way you want it to. Now, there's two things I want you to diagram with regards to load path, and this gets, I get that it's not always clear, especially because these things are complex. I want to understand the load path is just, we can pick a specific point and say, how did this load get down to the ground? One way to think about that is to like stand a person, stand a little figure right here, and say, how did that load of that person get down to the ground? Okay, so this is the loads going back. This might be a dash line, loads going back, loads going up, loads going over, loads going down, all the way to the ground. This is where stuff, we start to see how the things are kind of complex. Where is the path going? We stand somebody over here, right? It's going over, it's going up, it's going back, and it's going down. If we stood somebody over here, we would see that it's going over, going back, going down. You could have 3 different colors of different load paths showing the different ways that the load is going to get down to the ground. Okay. It kind of depends on the project, on what I want to show is interesting. Sometimes it's how weird the stuff is going. Sometimes it's about the accumulation of weights, because we could say, we could actually do a different plane here and say trib area, you could add up the weight of the concrete and saying that's going up, over, and down. This trib area.
Can you pull your paper down? We can't see it well on the camera at the top. Yeah.
Sorry, yeah. I'll do back out. So the idea of like taking, for this one, I want you to take, let's just do that as an experiment. For this one, I want you to put in 3 little figurines. No, I don't want crappy Illustrator. I want you to get nice silhouettes of people and drop them in an Illustrator. Get used to doing it with some effort. You should have your own catalog of people by this point. So the idea that you drop them in, and maybe it's 3 different colors, maybe it's something, and we're watching how that load path gets down to the ground, okay? And that's what's kind of different. And try to be unique here. If I'm standing in the middle of this, then it goes from here out the little joist, then over, then back, then down, right? Okay, that's the kind of stuff that I want you to follow through. If you're standing on the middle of this, it's going down to here, over, up, over, down, right? That's kind of how intricate this stuff is. So let's do that for this one. We're following the path of it down. Now, with regards to lateral in this one, I would probably look at the axon as a whole. Well, I have one of these drawings somewhere. Maybe not. Okay. I would probably have both, right? Have the whole project together in this. So how is this thing resisting lateral? Are there walls in either of the 2 X and Y's? Are there walls in X or Y? No, there's no walls in X or Y. So it's automatically not shear walls in X and Y because there's no walls. Okay. Is there X bracing or knee bracing in X and Y? No. So it has to be a moment frame, which is that they are. They're giant concrete moment frames. Okay. That's just, they're so big. Giant, they're so big, they're so heavy, the footing at the bottom is so strong, it resists overturn. That connection from here to here is so strong, it's literally just a giant concrete moment frame, right? So we could take one of these and say, moment frame. Okay, moment frame could be that way. You could be a little fancier this way and highlight this. And this is where the idea of editing and telling you a story, I want you to show me what's happening. I might highlight this one a certain color and write it this way. And then I might highlight this footing or outline this footing and say moment connection. resisting in this direction, because those are like the flagpole things, right? That's what's kind of stopping it in that way. Everybody just put in the planes and labeled. I want you to color code the thing that is that thing. Okay, I want you to say, this is the moment frame that's resisting this way. This is now in the Z plane, we've got concrete slabs on the floors that are starting to get us the lateral. So it's a shear diaphragm, just kind of standard. What's kind of interesting is that idea that that beam that was crossing at the bottom, right? It had that weird top edge, right? So we think about that, what that's doing is when that has a face here and wind is hitting that, that's actually, we could, in some ways, you could almost say that those beams have a little bit of bracing to them. That's kind of what's happening, is they're being thickened to resist the force in that plane. So it is a shear diaphragm, but the beams are actually reinforced to resist that horizontal force to transfer it down. So that's what's also really helping in that Z plane. Okay. So different scales, the idea of the diagram, the idea of the plan diagram to tell us maybe a little bit of the story, the shear, highlight these. It was funny, I kind of picked these projects because I said, oh, I'm going to do long span, and then realized most of the shear is pretty boring in all of these because it's just not what they were doing. It's like,
Can you zoom out a little bit more?
the
Top part. Yeah. Okay.
that idea of like showing us the plan and showing us trib area, maybe the square footage, and then showing us the axon so that we understand that this isn't the trib area. That's just maybe a smart way of showing that. Sometimes it could be the whole trib area. Sometimes, you know, a couple of you guys did, if you've got a nice simple project and it's a bay that's repeated and you show a little plan and just show that bay is what you've done, that's a great way of doing it. So, I mean, there's lots of ways of doing this based on the project. How do you just communicate what, like, I'll put it this way. I think everybody did a great first attempt from the ones that turned them in. And at the same time, I can see what needs to be done because I know the project. I want you to get to where you could show this to people that don't know the project and they understand what's going on. Because that's what you will use when you're trying to explain your project to somebody. Okay, so you got to get them into it. What are we looking at here? Oh, we're looking at that area of that column. Got it. I might even have a cool, like, column A written in perspective on that. Oh, that's column A. How do you have fun making this as graphic and technical as you can? Okay. If you want to go so far as to figuring out what the total weight is coming down under this column, because these trib areas, what is the weight of concrete? Concrete. That's its strength. Quick. Nope. Oh, yeah, that could be close. Yeah, I mean, yeah. There's a much easier rule of thumb that I just get to go scream at Tom or Fulton for not having you memorize. There's just certain things you just got to walk away with it. That. Okay, so 1 cubic foot of concrete. 1 cubic foot of concrete. 1 foot by 1 foot by 1 foot. I want everybody to put your hands on the table and put it about this to where I want everybody to push your hands and like go like, oh, this is about a foot off the table. And then this now, and I'm kind of understanding like how big is 1 cubic foot, right? Okay, how much do you think that 1 cubic foot of concrete weighs? One cubic foot of concrete weighs 150 pounds. It's dense. Okay, so 150 pounds, 1 cubic foot is me. Perfect, 150 pounds. 20 years ago. 30 years ago. Okay, so if that's 150 pounds, we can start figuring out stuff. Let's figure out what just this basic floor down here is, and we're going to be really cheap about it because I know it's hollow and it's got some structure. We're just going to pretend like this is a 6-inch deep slab. And let's say that trib area, what was the sizes we used? We said, we used all weird number 70. I'm going to go back. Let's make it this easy. Let's say the trib area is 100 feet by 40, 60 feet. Let's just say right now. So that's 6,000 square feet. Okay, so what is the weight? If the trib area for this column is 6,000 square feet and it's 6 inches thick, what's the weight of that floor? Do it in your head. Multiplication, one thing. There's one multiplication. The rest is log. So if this is 150 pounds per cubic foot and a slab is 6 inches thick, well, every square foot is 75 pounds. So I could either divide that by 2 mentally, or I could say instead of 6,000 square feet, I could just divide that by 2 since it takes 2 of them. I could say 150 times 3 or 3,000 square feet. So 15 times 3, 45. That's the only actual math you had to do. And then you just got to figure out the zeros correctly. It was 3,000 square feet times 150. You got 1, 2, 3, 4. 450,000 pounds. It's that easy. You just gotta think through it. This is what I want to get you to. It's like it really is just visualizing these things. If you know it's 150 pounds, cubic foot, a lot of times, even if it was 4 inches, I'd probably, well, if it's 4, then it's just divide that by 3, right? If that was a 4-inch slab, it's 3 4-inch slabs per cubic foot. I could divide that by 3, and then it just would have been 2 times that, right? So you could figure out the weight of each one of these beams, the weight of that floor, the weight of this, and talk about what all of that weight is coming over. You could figure out what all of this is, and that's what would be coming in and down here. And you can figure out what all of this is, and that's what would be going in and down here, and that would be adding up to the footing below, right? That would be a great diagram. You could actually do total load based on concrete for each one of those. Weight per square foot, weight per averaged over square foot, weight averaged per square foot. Those are all different, right? So that would be one thing. That's bonus because I want you to diagram the people and the path versus the, it's cool if you could do the whole trib weight and what's coming down. Those are both kind of considered load paths is kind of what you're talking about. So it's kind of weird. A load path diagram might show the whole weight coming through, but then also just show an individual path if it's a very dynamic path that you want to show how crazy it is. That's why it's all right.